when you walk in this classroom? What is the emotion?
I don't know.
Misery? So we're going to do derivatives of trig functions. My class is miserable, is what you're telling me. I'm going to try to explain to you like why the derivatives are what they are. In the end, it's just like memorize them, but I think it's easier to memorize if you have an understanding of like where they come from a little bit. So I'm going to try to do that. So we're going to graph sine of x. What's the biggest sine of x could ever be? 1. What's the smallest it could ever be? -1. And if we just start kind of working our way around, so let's start at 0. So 0 degrees is over here. Remember, sine's the y value. What is the sine of 0? What's the y value of 0 degrees? This is terrifying. 0. Right there. What's the y value? 0. Pi over 2. Pi over 2 is up here. What's the y value? 1. Pi is over here. What's the y value? 0. 3 pi over 2, -1. And then it makes, you got like your curve. So it looks something like that. And it's symmetric, right? So it's the same thing on the other side. So something like that. Well, I want to look at what the derivative of that is. I'll give you a second to draw that. So the slope of that. So there are 1, 2, 3 points, 4 points where I know exactly what the slope is. Slope is 0 there because it's going to be level. Slope is 0 there because it'll be level. Slope is 0 here. Slope is 0 there. So you get like the horizontal surfboard that we talked about for a little while. I didn't draw this very well, but the steepest this ever gets, this looks like it's vertical the way I drew it, but this really should be a slope of like -1. So the steepest this ever gets is -1. And then so what do you think that slope is right there? It's +1. And then this slope is -1. And if we connect those, that's our derivative. Well, what graph is that? That is cos. So the derivative of sine is cos. And I highly doubt that anybody's going to get to the test, not remember the derivative of sine and like graph it. But I think it makes more sense if you at least see where it came from. So that's the first one. There's 6 of these we're doing today. So that's the first one. Questions on like what I'm doing to get it?
Does it work the other way around?
Well, that's what we're about to find out. So, what if I gave you cosine? Try to graph cosine first on your own before I do it. Cosine is the x value. Actually, you can like look at the previous graph. This is cheap. So the cosine of 0 is 1. Cosine of pi over 2 would be 0. Then -1. Then 3 pi over 2. And then same thing going backwards. So cosine looks like that. Now I want to graph the derivative. So if I look at graphing the derivative, I'm going to start with where I know the slope is 0. So I know the slope is 0 there, the slope is 0 there, the slope is 0 there. And then the same thing, the steepest it ever gets is 1, and then like least steep it ever gets is -1. So the slope here is actually -1. Your slope here is actually 1. Your slope here is -1. And your slope there is 1. So if we connect those, what is that? Good, so it's not actually sine. Did you guys do these last year or no? The trig ones? Okay. Okay. So the derivative of cosine is not sine, it's negative sine. So what that is sine but like flipped over. So one of the shortcuts that you'll learn to remember is if this original function starts with a c, the derivative is negative. If it starts with a c, put a derivative or put a negative in front of the. Sped that up. Starts with a c, derivative is negative.
So it works with cosecant.
So it works with cosecant and cotangent also, which we'll get into. All right, so let's kind of start a list here. So if y equals sine of x, y prime equals cosine of x. Y equals cosine of x. Y prime equals negative sine of x. Well, what if y was tangent of x? I'm going to do this one not on a graph, but we're going to use a quotient rule. So, y equals tan of x. Well, what is tan of x? What does it mean? Sine over cosine. I don't want to use quotient rule unless I have to. But in this case, I don't have to. Well, no, quotient rule is fine, because there's no chain involved. Never mind. Quotient's fine. Quotient works. Let's do quotient. Quotient and chain suck, but quotient by itself is fine. Alright, so, quotient rule. Says you take the bottom, you multiply it by the derivative of the top. Well, what's the derivative of the top? Cosine. The derivative of sine we just learned was cosine. So that's my bottom times the derivative of the top. Minus the top times the derivative of the bottom. What's the derivative of cosine? Negative sine. All over the bottom square. You guys know that, so if I write like cosine of x squared, that's the same as cosine squared x. Like I could put the squared in either spot on that. Alright, so what's cosine times cosine? Cosine squared of x. And then wouldn't it be plus sine squared of x? Because you got a negative times a negative. All over cosine squared of x. True or false, I can cancel out those cosines. False. You gotta have one in every term if you're gonna do it. We don't. But there is one trig identity that you are required to know. And that's it. What's cosine squared plus sine squared always equal? 1. That's the Pythagorean theorem, really, if you break it down technically. But so you have to know that one like trig identity. Sine squared plus cosine squared equals 1. So this is really 1 over cosine squared of x. What's another way to write 1 over cosine? Secant. Are you just looking at your sheet? So, I'm like, oh, Naomi's really good at this stuff. Oh. Oh, wait. So the derivative of tangent is secant squared of x. And I've used this before. Like, I've gotten to a test, like in high school. I didn't remember the derivative, I didn't memorize them, but I was able to, okay, I know tan is sine over cosine, and just quotient rule my way there. I don't think that's the most common way to do it. I think it's easier to memorize, but I forgot to do that part, so I had to figure it out. Questions on that process, because I'm going to have you do cotan. So do cotan. Find the derivative of cotan. This one's a little trickier. I'll leave that up. So make sure you're starting with cosine over sine this time instead of sine over cosine. It's not cosecant, but there's a cosecant involved. I know, I was asking you. I'm talking to you. What you have? So think about if cosine squared plus sine squared is 1. What is negative cosine squared minus sine squared? Negative. You know, like if 8 plus 6 is 14, negative 8 minus 6 is negative 14. Same idea. So your quotient rule would tell you bottom times derivative of top. Remember, if it starts with a c, your derivative is negative. Minus top times derivative of bottom. And that's all over the bottom squared. So you get, and it seemed like this was a place where most of you got it. You end up with this. And then you're kind of stuck, but if you just think about, okay, what if you can think about it 2 ways. Like, if 5 plus 6 equals 11, negative 5 minus 6 is negative 11. So, if sine squared plus cosine squared is 1, then negative sine squared minus cosine squared is negative 1. Or think about it like if you factored out a negative 1. What's this part come out to? 1. So then negative 1 times 1. So you end up with negative 1 over sine squared of x, which we would write as negative cosecant squared of x. So make sure you realize the negative is not being squared. It's not like negative cosecant squared. It's a negative, cosecant squared. So y prime is negative cosecant squared. So again, starts with the c, your derivative is negative. Questions on that one? How many got to that? Cool. So, I mean, it's not like you ever have to do that again if you just memorize memorize it, but at least you understand where it came from, and maybe you can work your way there if you need to. Yeah.
So, if you put parentheses around the cosecant squared, is that right, or is it parentheses around the left?
So you'd have to, if you want parentheses involved, you'd have to do this, so that you're not squaring the negative part also.
Okay.
So either one of those.
Okay.
Good. Nathan, you want to do cosecant or secant? You pick. Secant. What's secant? 1 over cosine. Paige, do you want to do chain rule or quotient rule? Chain? Alright, then we're going to bring this up. And I'm going to write it as cosine of x to the negative first. We can do quotient too, it wouldn't matter. Does that make sense to me rewriting it? Just bring it up to the top, x when it comes negative. So your derivative now, big as the negative 1, right? Bring that down, reduce the power by 1, so now it's negative 2. You leave Mr. Packard alone, and then you multiply by the derivative of the inside. What's the derivative of cos? Negative sine. So if I rewrite that, I'll go down here. It would be positive sine of x over cosine squared of x. That's a little messier than we would typically write it. So let me break that down. Would you agree that that is the same as sine of x over cosine of x times 1 over cosine of x? Those are the same, right? 1 times sine gives you sine, cos times cos gives you cosine squared. But what's sine of x over x? That's tan. And what's 1 over cos? Sec. So that's your derivative. Derivative of secant is tan sec. It's not negative because it doesn't start with a c. Alright, do cosecant. So if you did, like last time we did chain, right? I said pick one, it didn't matter. If you want to do a quotient, you can do that too. They both work. You get to the same spot at the end. Yeah. You can kind of tell the pattern, right? Like, it's going to be the opposite of that, the opposite of that, and negative. Oh, but yeah, that's, I don't mind you checking. So, if I rewrote this, you know, sine of x to the negative first, so your derivative, bring down the negative 1, leave the sign alone, reduce the power by 1, multiply by the derivative of the inside. So now we get negative cos over sine squared, which is not wrong, it's just not like simplified all the way yet. And then I can make this negative cos over sine times 1 over sine, same way we separated it out before. And then what's negative cos over sine? That's negative cotangent. And then 1 over sine is cosecant. So times the c, your derivative is negative. That's kind of a nice way that that works out. So negative cosecant times cotangent. So you will have at some point, I wouldn't say tomorrow. I'm not eligible to do this tomorrow, but any day after tomorrow, I can give you a quiz of these. So I'll say put everything off your desk, I'll give you these 6 things, and you tell me the derivative. Yeah.
Could you write it the other way? Negative cosecant x times cotangent?
Yeah. So, I mean, is negative 4 times 8 the same as negative 8 times 4? You know, that's all. That's the same thing. So, yeah. Other questions? So the worksheet I handed out, it's really just to practice the rules, because the calculus part of it's really simple. But I'm just throwing chain rule in, which these will almost always have chain rule. The difference is now chain rules, the big guy's not a power. And every time we've done chain rule so far, the big guy's been a power. In this problem, what's the big guy? Sine. So the trig function can be a big guy too. And it gets really confusing when I make this whole thing square, and now we got to figure out what. So we get into like a big guy, a middle guy, and a little guy. So yeah, we get like a double chain rule. But for this one, I take the derivative of the big guy. So the derivative of sine is cos. What do I do with the little guy? Leave him. And then you multiply by the derivative of the little guy. And that'd be your answer. So I'm just throwing in that chain rule part, but really the main point of this is to practice those derivatives and just kind of put them in your brain. If the derivative has 2 parts to it, so like let's say y equals secant of x to the 4th. The little guy goes in both those spots. So the derivative of sec is tan sec, right? So the derivative of sec of blah would be tan of blah times sec of blah times blah prime. Does that make sense? I know it's weird, but I think that makes sense. So what's the derivative of secant? Tan of whatever, sec of whatever, and you leave the little guy alone. So you just leave that little guy in both those spots. And then at the end, you multiply by the derivative of that x to the 4th. So it'd be times 4x to the 3rd at the end. Do you get what I'm saying? Like you leave this little guy goes in both those spots. That's the only point I'm trying to make. Okay. Questions for me? Yeah.
So is that like all really simplified?
Yeah.
Okay.
Yeah. So your goal, your jobs are like one term, and you can't have multiple fractions. Well, that's one term, and there's no fractions anywhere. So yeah. So some of these are tougher, but the nice thing is they're shorter steps. You don't have to simplify as much. So tomorrow we get into like, okay, now what if it's y equals sec squared of sine of 4x, and we start putting like layers upon layers and combining rules. So if you don't know these derivatives, you're going to be in trouble, because you're going to be trying to keep up with what's going on as far as the new material, plus you're going to be like, wait, what's the derivative of sine? You're just going to be, it'd be like learning algebra without knowing your multiplication. So the faster you know those, the better off you'll be. That's basically why I'm giving this worksheet, just to make it practice. Alright? So work on that. If you got questions, let me know. Answers are on there. Yes, ma'am. Okay. That's just like so when it's multiplication, like I don't care what the order is. So I think on the if this problem were on the worksheet, they would probably put the 12x squared in front. But those are the exact same answer, right? So it doesn't matter which way you leave it. You should be able to identify they're the same. I don't care which way you write. Good?